Hey there fellow Factorians, Onerous here with another Factorio beginner tips, and this one we are covering something that is really interesting. It is circuit networks. This is something that when I first started playing I avoided like the plague because it seemed way too complex and just not necessary. And necessity is an interesting word in Factorio, of course, but yes, you can launch a rocket without ever touching the circuit network, but there are many ways that it makes life so much easier. And I'm just going to run through some of the uses for it, what it does, those kind of things. And I'm not going to go into too much detail on these guys up here, which I'll talk about later. But I will put a link to the wiki, the Factorio wiki, which has an excellent tutorial on what they can do. Alright, so let's start with what the hell is the circuit network? Well, the circuit network is just a bunch of wires that carry a signal. And you can hook these red and green wires up. Once you've researched circuit network, you can build these. They just take copper wire, I believe. Let's have a look. Again, I'm in creative mode just to make life much easier for the building of the things. Oh, there you go. It takes a bit of green circuit as well. So once you've got it selected, you can click on just about anything and you make a connection with the wire, and then you can click that onto just about anything else. Just about, but not everything. So pretty much anything can have an input or an output, except for a few objects. And as you can see, an assembler is one of them. So what does it do? The easiest way to do that is to go over here. And as you can see, once it goes onto a power pole, you get to see what's happening. So once this is connected with a wire, you get this option up here, which is connect to the circuit network. So it is now connected. And depending on what you are connecting, you'll get a few different options. So over here we've connected to a roboport, and once it's connected, our options are we can read logistic network contents. And as you can see, when I hover over here, because I'm in creative mode and I've got these passive providers that just provide everything, you can see I've got everything, a signal that contains everything. Alternatively, you can just change it with this toggle switch to read output robot statistics, and then we'll see that I have corresponding to here, so total logistics is Y, total construction is T, and when I hover over here you can see Y and T are both 2000 because I have 2000 bots available in the network. What on earth is this good for? Well, at its simplest form, if I hook up a whole bunch of these, now one little tip that is super helpful is, and some might consider it a little bit cheaty, but if you use the Control-C or your copy function and select something that has wires, so you can see this has red wires. Now I don't have any red wires here, but if I just paste on top of here, suddenly the red wires appear. And I haven't actually used any red wire from my inventory, so if you're setting up big runs of wires, you can do that. Anyway, what I have done here is connected all these up via red wire at my little train loading station here, and I can now hover over one of these power poles and see exactly how much iron ore is in the network, which is fantastic. And there are so many things that you can hook up to. I can let's get my green wire here. I can hook this up to my train stop, for instance, and the train stop here has 4 options that you can do. And as you can see, they are not actually exclusive. They're not a radio button; they're a checkbox. So you can do multiple things with this. So yeah, as you can see, it changes what it does. So this is the train station. So the EnableDisable is actually enabling or disabling the train. So if you want to say, I'm getting ahead of myself. We are just currently reading the volume there. So that's a great use for this. That's probably the simplest use, is just to see how much of a thing you have available. The next one up is, let me just get rid of this guy. So here I've just got a, while I'm doing this too, to remove a wire, you do exactly the same as you connect it, click on the start, and click on the end, and it removes it. You don't get the red wire back. So just remember that if you're running low on circuits early on. So another good use for this is I've set up a little thing here that you might see in a mall where you've got red belts feeding into a box, and I've blocked off this section because I only want 1,000. And then suddenly I've got some in my inventory and I'm like, I can't control click to put them in. Why? Because this is all blocked off. Well, there's another way to limit the output here. And all I do is I connect to the chest and I connect here. So if we click on the chest now, we see the only option you got with the chest is read contents. So now when I click on here, you can see the circuit network now has a couple options. Stack size, not used that often, but EnableDisable. So we can enable or disable this inserter based on conditions. And this is where the circuit network really shines, when you start using conditions. So I want to say if red belts are less than 1,000, then I want you to work. And so currently we have 1,000 belts in here, so this is disabled. So I can clear this filter and it won't work. If we take away a few of these though, all of a sudden it starts pumping it back up to 1,000. We pop all these back in now and voila, it's stopped. So this way you can have your box fully available to throw stuff in and out of your inventory, while still only limiting the actual production if this drops below 1,000. A fantastic thing to throw in your mall once you're up to that point. The next big use, and this one honestly has to be one of my favorites, is when it comes to cracking. Yes, so oil processing, you're in advance, you've got heavy oils, you've got light oils, you've got petroleum. You want to use a lot of petroleum because that's what a lot of the products end up being. But at some point, you don't want all your heavy and light oil going into petroleum. So if you've got cracking set up, and I've got the example here of light oil. So we're producing light oil. This is a light oil source. We've just got unlimited light oil here. And I said, oh, I want to start making some excessive amounts of solid fuel to maybe fuel your trains or whatever. And so I've got this here, but I've also got cracking going. So if I just disconnect this source, so this starts now using it all up. And let me just make sure that we are actually using this up. What is going on here? Fluid void. There we go. I had it the wrong way around. Yeah. So here we go. This is using heavy oil to crack into petroleum, and this is using light oil to go into our solid fuel. So all of a sudden I say, well, I actually want to make sure I have solid fuel going. I don't want to be cracking if I don't have enough light oil for solid fuel. So what we can do, we'll just reconnect this. We can hook up our storage tank. We'll hook it to the pole to see. There you go. Now we can see we have exactly the quantity of light oil. This can be connected to a pump. In fact, we'll connect it to both of these. So this is the pump that is supplying the cracking. Well, I don't want this to be cracking if we're running low on light oil. And you'll see there's a new tab here that's not available in crafting, which is the fluids, because you can't craft these. But so if I say I only want this to be enabled, this is the enabled condition. Enable this if light oil is greater than 10,000. So now, when we've got more than 10,000 light oil, this will start going. And let's just quickly empty that. So now you'll see, once we hook this up, there we go. We've got. Why are you? Oh, hang on. Let's try that again, because I foolishly had the network connected. If you connect it, and there's actually no condition, it just won't start. So here we go, we've got less than 10,000 oil, and as you can see, that little light is red. This is not going, but this one is. So we're making our solid fuel, and then all of a sudden, this should be working. What have we done? We have disconnected somehow when of course. Silly me, we didn't connect this back up. There we go. Alright, let's try that one more time, because I swear it works. Now Now let's, oops, always click there. Let's hook this in first. There we go. So now we have the light oil. Okay, let's run it here. So here we go. This is disconnected. We have building up our light oil. Light oil's going, and then hits 10k, and suddenly we start pumping in. And as you can see, it was flickering a little bit because as soon as we hit 10k, it started pumping out, and the supply didn't meet the output. So this way, we can say, okay, well, that's prioritizing this, and if we have more excess, more than 10k, we'll start cracking it into petroleum. Another little trick that you can do that we probably need to just add a couple more items in to do, and this is one of my favorites. We can actually connect a circuit network to the belt. So let's connect that here, and let's see. By default, it's EnableDisable, but we can read the belt contents. Pulse hold, you'll play around with that if you get into the advanced stuff. But here we can see we have 7 or 8. So it's not quite a full belt. We have 7 or 8. It's flickering between the two. And if I bring this all the way over here, we can actually connect this into this signal. So now we have multiple signals going into this one network. As you can see, everywhere that it's connected carries the same signal. So now we've got the light oil coming over here. What I can do now is, instead of saying, well, I want this to be greater than 10k, what I really want is for this belt to be pretty much full. So I can say, enable this if solid fuel is greater than 6. So provided that and the point being here, a belt holds 8 items. Important fact to remember if you're doing this. So 8 is a fully compressed belt. 6 obviously is a fairly full belt. And as we can see, we're floating in between 6, 7, 5. All right. So whenever we have enough solid fuel here to fill that belt, we can then start cracking. And as you can see, we're flickering along nicely. Sometimes it's on, sometimes it's off. And that's just because we don't quite have the right amount, but I could change this, of course, down to, say, 4, so we've got half a belt, which is a fair bit of solid fuel. Let's not be crazy. And normally you wouldn't be using this much, it'd be backing up. So anyway, that's a great way to ensure you have solid fuel going, and then the rest of your stuff is going into light oil. Now, one thing to note here too is I've got 2 pumps here, and this one's not connected. I don't know if this is true, but anecdotally I've found if I have a pump here and then this just piping through, this will kind of get prioritized, and a lot of the fluids would go through here rather than down here, which in this kind of situation isn't too bad, but there are niche cases where that is a problem. So that is a great way to control your cracking with the circuit network. Now, we've looked at these. Let's jump into the thing that really makes the circuit network totally ridiculous, and that is combinators. Let's pop another one here. Alright, there's 3 types of combinators. There are constant combinators, arithmetic combinators, and decider combinators. Constant combinator, super easy. You set a value, and that's what it outputs. You can set multiple values, and it will output those exactly. What you use that for is entirely up to you. There's many ways to play around with that. Next up, we'll look at arithmetic combinators. So these take an input and an output, same as the deciders, and perform an action on it. So in this case here, I've got a box. It's got some stuff on it, and we want to have an output. So here, there's these new operators, and this one is called each. There are some other ones available, everything and anything. So again, I'm going to point you to the wiki tutorial on this because it explains it way better than I could. But essentially, the each operator looks at every individual signal. So if we look over here, this has 4 signals on it. Let's change that to that, and it's got just a whole bunch. The each will perform an operation on every individual signal. The everything looks at every single and performs an action on them all, but only returns a result if they all meet the requirement. So this is essentially an AND gate if you're looking at computer technology. And then the other one is anything. So again, it looks at all the signals that are coming in, but if any of them meet the requirement, then it will output. So this is essentially an OR gate. But as you can see, I've got here, so I've got the each and a output of each. So this one here takes every signal in, multiplies it by -1, and then outputs every signal. So we'll see that in action. We've got 100 red belts, 33 undergrounds, and the output from this is -100 and -33. So yes, you can have negative signals, and that comes into effect if if I add, what do we have? We had red belts here. If I put 100 here, you'll see that's outputting 100, that's outputting -100. We combine them together, all of a sudden the red belts have disappeared, because that is just how they work. So when 100 is added to -100, 0, and 0 is no signal, which is a good tip to know when you get into more advanced stuff, which I'm not going to really cover here. Refer you back to the wiki if you want to go further. No, you don't actually have to output the symbol here, the each. So if I output that, all of a sudden our 133 of now outputting -133. It's just added the two together and multiplied it by -1. So that is an interesting way to combine. There's also a whole lot of lovely colors here, so I can make that yellow, -133 yellow, which again, niche uses, but way more advanced than the beginner tips are going to cover. So that's arithmetic. You can multiply, you can divide, all these things. Mode, is that mode? No. Whatever it is, the remainder. Man, the math escapes me now. And there are some ands and ors. Good times, but let's get on to decider combinators. So decider combinators are your greater than, equal to, not equal to, all that. So again, let's have a look. We've got 100 red belts, 33 underground pipes. So here I've got everything, and we've got less than 50, less than 50. So here I'm saying if everything is less than 50, give me a green tick, and I'm just having one green tick. As you see, the output of that is nothing, because even though this is less than 50, that's not. So everything is not less than 50. No tick output. Likewise here, I've got anything. So this is your OR. If anything is less than 50, then output a tick. And of course, that is getting a tick because one thing is less than 50. Yeah, so we've got all these things are fantastic. And let's just do a quick little case over here. So yes, I've got my train station here, and I want to say, well, I know how much iron ore is here. A train holds, I think it's 4,000. No, 8,000. 8,000. Anyway, let's just say it's 8,000. So a carriage holds 8,000. We've got 4 carriages here. I only want to enable this train station if there is more than 32,000 iron ore here. So how do we do that? Well, we connect our red circuit to the network here. Also want to point, green circuits and red circuits do not cross over. So as you can see, the number 57,000 is noted in red in the background. That means it's on the red circuit, and there is nothing on the green circuit. So we could hook it up to just up to here, just have something on there, and just read the belt contents. There we go, and we'll see we've got 8 iron ore on the green circuit, but they're not combining. So that's an important fact. Anyway, back to here. We want to say if iron ore is greater than or equal to 32,000, because that's how much we need for our train to actually be able to pick it up and fill, then let's output let's output a tick. Let's do something different for this one. Let's output a an eye, because it just doesn't matter. And let's output one eye, regardless of what it is. Or we could output 32,000. Anyway, what we do then is let's put the output here onto here, and I'm using a green wire to delineate it from the input. Not required. I can easily use a red wire. Let's get rid of this green wire here. There we go. I can easily put a red wire here too, and that is still separate from the input here, because there is no connection in between the middle here. So what I want to now do is I just want to enable disable this if our I value, whoops, if I is greater than 1. There we go. If I is greater than 1, enable. No, not greater than 1. We'll see there's a greater than or equal to, or I could go greater than 0. It's probably a smarter way to do it. There we go. Alright, so that is now enabled. And if we, just for the sake of argument, increase this to 64,000, which is more than is available, you can see this train is disabled. Who we got there? Godfather Bobo. Wonderful. Alright, so that is a quick way to enable disable trains, and that means that you can avoid some trains traveling through your train network to sites that aren't ready for pickup. Man, hope I haven't gone into too much detail, or if you want way more, again, I'm going to point you to the wiki that I'm linking in the description below, because that's where you can start actually getting some amazing things happening with the circuit network. Playing around with decider combinators and arithmetic combinators and constant combinators. There's some amazing things that you can do. You can set request to chest requests based on stuff around. You can fill trains, unload trains based on other conditions. Man, the options are endless, and if you start going through to a mega base, then there's probably a lot of places you'll be using the circuit network to make your life easier. So again, I really recommend you jump through the tutorial that's in the wiki, and even if you don't use stuff, it'll at least make you aware of the kind of things that you can do, and if you get to a situation, you'll be like, hey, I remember that thing is possible. So there we have it. That is the beginner circuit network introduction, and from here the sky is the limit. You should see some of the stuff that people got created in Factorio, because essentially these are computer transistors. You can actually make computers. There is a guy who created Doom in yes, the original Doom game in Factorio, and it is a sight to behold. So do have a look through. Yeah, it's a massive rabbit hole. Sorry if I'm sending you down it, but man, there is some awesome stuff out there, and the possibilities are almost endless. So, as always, look, thanks for watching. I hope you learned something. Feel free to leave me some comments below. If there's something I've missed that you want to hear about, do pop it in there, and I'll try to produce a little quick video on it. Otherwise, I will direct you to my playthroughs. I'm currently on Death World. We're about 50 episodes in. It is a fun little thing. Biters, there's been a recent update. 0.17 stable, about 70 or 71. They changed the pathing on biters. They changed the collision on biters, and suddenly biters are even worse. So yeah, it's fun times in Death World at the moment. There's also, if you're just starting out, I've got a beginner-friendly playthrough that starts on version 0.17 before the 0.17 stable oil changes. I'll throw that out there. I've also got a Mega Base series if you're ready to start pushing up to 1,000 signs per minute, but all that's linked down below. Jump on, enjoy. Otherwise, I'll see you around.